Good morning. I hope everyone is doing well today. We're going to start in chapter 9 today, classifying and evaluating polynomials. So before we get started, let's do a little bit of review. X plus 2x. Well, are those common or like terms? Yes, they are. So I can combine like terms. X plus 2x will give me 3x. What do I need to do right here? Well, I need to distribute that 7 to everything inside the parentheses. So it's 7x minus 7 times 9 is 63. That's a negative 63. What are my like terms in this example right here? Well, just negative 4 and positive 8. So those are the only ones I can combine to get 3x plus 4y. Down here, I need to distribute first and foremost. So let's distribute. That's 3x plus 15 minus 4x. A negative times a negative 2 will give me plus 2. So 3x plus 15 minus 4x plus 2. Do I have any like terms? Yeah. 3x and negative 4x, positive 15, and positive 2. So 3x and negative 4x will give me a negative x, and 15 plus 2 will give me 17. This is my final answer. 6x plus 11, I need to distribute that negative 4. So I've got 6x plus 11 minus negative 4 times 2x is negative 8x. Negative 4 times positive 3 is negative 12. Like terms, 6x and negative 8x, positive 11. And negative 12. So my final answer is negative 2x minus 1. A term. It's a constant. Well, what's a constant? It's a number, like 7. That's a term. A variable, x. Or the product or quotient of a constant and one or more variables. So I could have 7x, or 7 divided by x. Each one of these are called terms. Made up of a number, a variable, or the combination of a number and a variable. 7 plus x, that is not one term. That is actually two terms because it's divided by a plus sign. Same with 7 minus x. That's two terms. Oops, sorry, I didn't know I was going to write all over that. 2x squared plus 3x plus 5y minus 4x. Woo, that's an algebraic expression containing 1, 2, 3, 4 different terms because we divide them by plus and minus signs. A polynomial. What is a polynomial? Okay, it's an expression. Let's go through it word by word. So an expression that can be written as a sum. Sum is when we're adding things together. A sum of terms. So we've got a term plus a term with consisting of constants, there's a constant, variables with non-negative integral exponents. Okay, don't let that scare you. Or the products of a constant and one or more such variables. All right, we'll look at some examples here. A monomial. Do you know what mono means? Mono means one. So you can remember a monomial is a polynomial. What does poly mean? You know what that means? That means many. So a monomial is a polynomial with exactly one term. A polynomial has many terms. What do you think bi means? Bi means two. So binomial is a polynomial with exactly two terms. So one term, x. A binomial is two terms, so 2x plus 1. And a trinomial, tri means 3. So we've got, we've got 5x squared plus 2x minus x. And there we go. 4y cubed is a monomial. Why is it a monomial? It's just one term. This is a binomial. One term, two terms. This is a trinomial. 1, 2, and 3. 1/2 x is a polynomial, but x cubed y to the negative 2 is not, since it has a negative exponent. Okay, so hold up. A monomial is a polynomial. A binomial is a polynomial. A trinomial, all these are polynomials. 1/2 x would be an example of a monomial, but it's still a polynomial. X cubed y to the negative 2 is not, though. Why? Because according to our definition, can we have that negative exponent? No, we cannot. That is not a polynomial. The degree of a term is the sum of the exponents of its variables. Okay? The degree of, here's an example, 5x cubed y squared z to the 4th is 9. Why? Because the degree of a term are the exponents added together. Exponent of 3, 2, and 4. So, what's the degree of 4x squared y? Well, it would be 3 because exponent of 2, y has an exponent of 1, that's 3. The degree of a constant or a number is going to be 0. So if I have the constant 2, the degree is going to be 0. So, 2 is not equal to 0. Hopefully that doesn't confuse you. But the degree is going to be 0. The degree of a term is the sum of the exponents of its variables. The degree of a polynomial is the highest degree of any term. Do y'all see the difference between these two? So the degree of a term, we had 4x squared, y cubed, z. The degree of this term would be 2 plus 3 plus 1, which would be 6. So that's the degree of a term. The degree of a polynomial, though, is going to be based off of the highest degree of any of the terms in the polynomial. So if I have the same polynomial, the degree of this polynomial would be 3 because it's the highest degree of any term in this polynomial. So I've got x squared, y cubed, and z. Y has the highest exponent. So 3, that's going to be the degree of the polynomial. Here we go. 3x cubed y plus 2x minus 4x y squared. This is our first example here. State the degree of this polynomial. So the degree of a polynomial is, finding the degree of each term, we've got, let's see here. So the degree of this first term right here, So the degree of this first term is going to be 4, because that's 3 plus 1 is 4. The degree of 2x is just 1, because you take the exponent of the variables. And the degree of this last term right here is going to be 3. So the degree of the polynomial is going to be 4, because you take the highest degree of that polynomial. So, you know what? I was incorrect on this example right here. The highest degree of that would also be 6. I hope that did not confuse you. We'll have some example problems soon up. The polynomial is written in standard form when the terms are arranged in order of descending or going down degrees of one of the variables. So notice here, this is going in descending order based off of the exponents of the variables. Our variable is x, and it's going in descending order. X cubed, x squared, x to the first power, and guess what? There's actually x to the 0 power right there. But what is anything to the 0 power? It's 1. So 3 times 1 would just be 3, so we don't even need to put the x to the 0 power there. So we write it in standard form when we put our variables in descending order. Lots of terminology, so stick with me, okay? Polynomials are evaluated by substituting the given values and following the order of operations. Let's look at an example. 2x squared minus 5x plus 6. Evaluate this if x equals 3. Well, we're just going to plug in the value of x as 3. 2 times 3 squared minus 5 times 3 plus 6. That's 2 times 9 minus 5 times 3 plus 6. 18 minus 15 plus 6. Our final evaluation is 9. Let's do another example. X is negative 2. Y is 1. So let's just plug in our values. Remember, put it in parentheses whenever you plug in values. Okay? 5 times negative 2 cubed, and so on and so forth. Simplify your exponents before you distribute. You can't multiply 5 times negative 2. You have to do negative 2 cubed first. So, do your parentheses, your exponents, that comes in your order of operations. 5 times negative 8 times 1, and so on and so forth. Now let's simplify. Negative 40 minus 4 minus 3 plus 5. My final answer is negative 42. All right, we're going to do a few example problems. I'll be on page 372 to 373 in just a minute.